Hello, everybody. I wanted to welcome you to today's session. This is CS Ed Week. We're going to be talking about CodeBytes today. Unfortunately, the meet that I just finished with about 35 or 40 people, somebody didn't push the record button, so I get to do this one more time just for the recording, just to make sure that everyone has the opportunity to see what CodeBytes are and what the purpose of them are and so forth. So even though we won't have any feedback coming from the chat and from the people who are in there, that's okay. We will go ahead and do it from here. So again, welcome to this session, and it is again, it's over CodeBytes. And the agenda for today is well, I should start with this. This week is CS Ed Week. And what that is an annual program dedicated to inspiring K-12 students to get interested in computer science. And this is true whether or not you teach a computer science classroom or not. So if you teach computer science, you're probably aware of a lot of these things, but there might be some things in here that you can pick up on. But if you don't teach computer science, that's kind of what this is designed for. If you don't teach computer science, it's really kind of it's me kind of asking the question, why not? Why don't you incorporate a little bit of computer science into what you're doing? Because I really think there is a lot of benefit for that. And so this is not meant to upend your curriculum to completely replace what you're doing. Not in any way. In fact, the opposite. These are just little bite-sized, code bite-sized pieces that you can kind of throw into your curriculum with the idea of improving that curriculum, not just something that goes in the corner and we point at it and we say, oh, look at that fun thing over there that we're going to do later. This really can be something that you incorporate to teach to the standards using the district adopted curriculum as you go through. So with that in mind, now the agenda. We're going to take a look at why you should participate in Computer Science Education Week. And I already kind of went into it a little bit, but we will look at it a little bit more. We're going to look at what are CodeBytes, what do they do? More specifically, we are going to look at two different CodeBytes. One is AI for Oceans, and the other one is a dance party. And don't click away from the video. I will not be dancing today, so you are in luck. And then we're gonna kind of show you additional CodeBytes and additional resources, places to go that you can get some of this information. Okay, so first, why should we participate in Computer Science Education Week? Why should we even teach computer science? If that's not your job, if you aren't a CS teacher, why should you care about that? Because computing and technology jobs in the state of New Mexico are very available, and in fact, there are 2,311 open computing jobs right now. I guess this information comes from the beginning of this fiscal year, so it's a little bit dated, but that is 3.3 times the state average demand rate. But we only have 173 computer science graduates that graduated last year. And so the supply is very low and the demand is very high. And with those jobs, they come with a very good starting salary. It's significantly higher than the average salary in the state of New Mexico. So these are not just jobs that are available, but they are good, high-paying jobs that can support families in the state of New Mexico. What are these jobs? They range. There's quite a few things, but just in this area, the most needed job is a software engineer, a systems administrator, a .NET developer, help desk, and a web developer. And so the demand for these jobs, is growing on a daily basis, and not just even though they might be a little bit different depending on where you are in the country, they are needed in a lot of aspects. And so the good news is that what we can do with CodeBytes and some other things inside of our classes is we can kind of get those kids that interest that they need in order to really see CS, computer science, as a viable career path for themselves. And so because coding jobs are available no matter really what their strong suit is in education. So whether they are science minded, there's computer programmings that allow them to do experiments along the way. If they are just into technology and writing software and playing games or apps or whatever that is, in that area, then maybe they can go into the IT field. My brother is an engineer, and there is coding that he can do for those that that love to just do those new products and just build stuff and things like that. If they are more of a if they have more of a mind of creating artwork and stuff like that. You have arts and designs. We need designers for that in the coding field. And finally, if they're a mathematical mindset, then we have data analysts. And as teachers, we are always being asked to analyze data. Every single Wednesday we need to sit in PLCs and we need to analyze the data that comes in and out. And so how can we how can we build some of those skills inside of this coding job, and we can do it pretty easily through what we have available to us. And the computing and technology jobs are not just limited to the your highest performing students, and in fact some of these jobs don't even require a high school, a college graduation. They don't require a degree of any kind. They can get it in high school or community college, and we take a look at some of these, and I kind of look at this bottom one here of a job developer. This is, by the way, this graph says increases in tech job postings. So this is not by, this is not done by, income or ability or anything like that. This is just, how many jobs are being made available and an increase in. And we have like a Java developer. I mean, we kind of starting off in early elementary, you can kind of start them in the idea of coding with block or coding with Scratch, and kind of moving up and maybe taking a look at web development and JavaScript and Java, and once we get there, then they can get there are jobs available to them and that they could really theoretically get even while they're still in high school. And so so there's a lot of stuff out there, and I think it's important for us as teachers to kind of let them know that stuff is out there. We're always talking about the jobs that were available to us when we started school or finished school, but the reality is that there's a lot more out there that we need to make them aware of. So where I want to go with this next is I kind of want to take you here. This is a picture of me, Anita, and Andrea. We got to meet the man in the middle right there. His name is Jamie Cassup, and he is the Chief Education Evangelist for Google. Basically what it means is he's the head of Google for Education. And he kind of is the team leader on where the direction that Google goes in the educational sphere, I guess. And just a little bit about him. He grew up in Hell's Kitchen, New York, and he joked when we heard him talk that it's not really the sophisticated place that it has turned into, but he said that the movie Escape from New York, he thought that was a documentary, right? He grew up in the rougher part of New York. Yet, even with that background of basically growing up in that difficult area, and being the son of immigrants and so forth, he was able to be at the top of his basically the top of the game in education. And although he's not an educator himself, I should say his background is not in education. He actually has started schools now and works at a school where he teaches. But that's not where he came from. But yet he was able to achieve, what really almost no one else in the world has been able to, is to start, kind of take Google from being not on the educational radar, really 10 or 12 years ago, to being the go-to place right now. A little bit more about Jamie. He's got a couple kids. He's got 3 kids, I believe, but he's got 2 of them that are either just starting or have finished their college education. And he said that he never talked about going to college. He never had a conversation about them or with them about college. They all just thought that that's where they were going to go. Even though Jamie himself, his parents never went to, higher education, because he did and because his wife did, then his kids just thought that they were going to go there. And they got, one of them has already got a graduate degree, and because that's just what they assumed would happen. And it kind of makes me think, as teachers, we prepare our students, not just with the things that we have them do, but the way that we show them the world. And, Jamie's kids and a lot of, teachers, maybe, some of you that are watching may not have really had that conversation with your kids whenever they finished high school, whether or not they were going to go to school, because they just assumed because you did that they would, because you showed them the way, you led that path for them. And so, the question that I kind of have this morning is what are we showing them now? And what are we showing them now compared to what we were showing them 12 months ago? How would you have answered that question? And in the meet this morning that I had, the question I asked is how many of you who are watching this then or now have teach in the lower elementary setting, so pre-K, kinder, or first grade, and how many of you have the kids play school? And one of the teachers spoke up and said that they have kids that went before lockdown started, that they would play school and they would set up dolls and they would go up to the board and they would write. And that's what we think of whenever we play school, I guess, because that's what the kids see. That's the world that is known to them. But I want to introduce you to my daughter, and her name's Carmen, and she is not yet in kindergarten. She'll be going to kindergarten next year. She's on the moon right now, and I'm sure me and my wife would like to send her there a few times, right, just to get a little bit of peace and quiet in the house. But no, this is a picture that she took, and you can notice the green around her hair. That's because she's standing in front of a green screen. And she came to my office one day, and we have a green screen set up here so that we can do, show off some work and do some videos and whatnot. And she just needed to know what that was and why it was. So I went ahead and showed her, and we did a fun little thing with it. And so we put her on the moon so she knows what a green screen does now, right? Well, when she plays school, though, and this is kind of where I was going with this, when she plays school, she doesn't set up her dolls and go to a board and teach. When she plays school, she sits in front of a computer and she kind of taps on the keyboard every now and then she says, "Oh, don't forget to mute yourself. Don't forget to unmute yourself. I can't hear you. You're going to have to unmute yourself." And because that's what she thinks school is at this point. And for one, how sad. Yes, how sad that she has that image. But that is the reality. That is the world as she sees it. And I think it's important to think about how quickly the world as we see it can change. And as an example, this generation growing up is just in a completely different world than we could have ever imagined 12 months ago, but especially going back like 15 years. 15 years, as an example, the iPhone did not exist. The BlackBerry, which is now a dinosaur, by the way. If you use one of those, you need to get put into a museum of some sort, just so we can, keep you there, and so that you don't spread that BlackBerry issue everywhere else, I guess. But 15 years ago, Blackberries didn't even exist, and as I said, there are dinosaurs now. And just a bit, before 15 years ago, if you remember this, we used to have to call the internet. Sometimes the internet was busy when you called it, and you had to call back. And now it's think about going to a hotel and there's Wi-Fi everywhere. Go to a hotel one day and tell your kids that they don't have Wi-Fi there, and they're not going to know what to do with themselves. They're going to think that they're going to be staying in a cave instead of an actual hotel or something. Because because we have changed so much in that time. And so why do I bring this up though? Why do I bring up, kindergartners thinking school is nothing more than a series, an hour long, telling people to mute and unmute themselves, and so forth? Because we have to prepare them for the world that we and them can't even imagine yet. We have to not just show them the opportunities that are available now, but we have to show them the opportunities that don't exist yet. We have to inspire their mind, I guess, to think of a career field that isn't obsolete, by the time they get their degree in it. And this is not going to happen if we treat school the same way we did 100 years ago, and the way that we did it even 12 months ago isn't good enough. And so we have to show them in ways that we never thought possible. And again, that doesn't mean throwing everything out. That doesn't mean starting from scratch. But it does mean incorporating things that maybe we don't feel comfortable incorporating for a little bit until we get more familiar with it. So with that in mind, today I want to show you a couple different things that you can do inside of your classroom to kind of spark that imagination, but also hopefully with the idea that you can take it into your classroom, into your regular curriculum, and still do the things that you were doing, but make it look a little bit different. Okay. So the first thing that we're going to do, and if you are following along, go ahead and go to code.org/oceans. So code.org/oceans. And what this is, it's called AI for Oceans, and it talks about artificial intelligence. And again, I'm not recording this with a host of people inside of the chat that can interact with me. But the question is, what is AI? What is it? First of all, do we have any examples of AI? What do we do with it? And this morning, a lot of the examples were based on Siri for your phone, or the G assistant that I can't say out loud without triggering my cell phone, Google or Alexa, or I think they said Sonos has another one now. There's a lot that are available now, and that's kind of where the discussion kind of centered around. And these AIs that they're really there for us to do tasks that we don't really need to do anymore, that they can do for us, like looking up random facts on the internet that we didn't know existed, or we're getting ready in the bathroom and we need to know how much time we have before we have to be at work, so we ask it what time it is, stuff like that. And while yes, it is fall under the category of artificial intelligence, it's not. It's being programmed in order to do those things. And just to kind of give you a generic term for what is AI, it's a computer or program that doesn't need to be explicitly programmed to do something. And it's a way of a computer, the way that a computer is programmed to do something that seems like it has human intelligence. Now, that doesn't mean that it thinks for itself, although that's kind of where the goal is, I guess, in AI, is to get it to think for itself and to do those things, and then we can, then they'll be hiring us probably. But really what we do with AI, or the work that's being done with AI right now, is built around the idea of we give it a lot of information and it sorts it out, and we don't have to tell it how to sort it out. It will sort it out on doing it on its using its programming. And so in that case, it does kind of think for itself, because it's going to sort, it's going to organize things in ways that make sense to it. And that's what we're going to be doing with AI for Oceans. And so first of all, before we click on that, I want to look down here, and there are teacher resources that you can click on. And this is something, again, you can do with your kids. This says from grades 3 to 12. I think you can do it for grades younger than that, because there's really no work on their half to get this to work, and there is some reading that needs to take place. But if you do it with them, if you are kind of following along with them or guiding them through this, then I think it can be done at the younger grades. But here is the lesson plan that is available, and you can click over here and click on the lesson plan PDF, and you can see that that you'd be able to print that for those of you that like to print. And but this is AI for Oceans, and you have an overview, you have your objective, you have different links, you can download these videos. If you want to send them to your students via Google Classroom, you can download the videos and do that. But it gives you the teaching guide, the warm-up, the activity, teaching tips. I mean, it gives you everything that you would need in order to deliver this lesson to your students. And so it gives you a lot of information so that you don't have to have previous knowledge of AI or oceans or anything. You just need an open mind in order to get started. Okay, so this is the lesson plan for that. But going back in here, and there's also a CS for Good that I'll kind of let you look at if you wanted to take a look at that. But it's resources to help students understand the role of computer science. But we're going to get into that just a little bit right here. So I'm going to click on Try Now, and it's going to start off with a video, but I am not going to go into it because we kind of already did. We're talking about how AI works, what is machine learning. If you don't have the background that I do, because I just find this interesting and I want to find more about it, then just show the video to the kids and they can kind of work through it, right? But here is the AI, and it's going to talk about the program, and it says garbage dumped in the water affects marine life, and this activity will program or train AI to identify fish or trash. So we're going to clean up the ocean. We're going to create an AI bot to help us clean up the ocean. And so this is the AI bot that will be helping us, and right now it does not know anything about the ocean. It doesn't know whether anything is a fish or whether it's trash. But what we're going to do is we're going to take a look at these pictures and we're going to identify for it whether or not something is fish or a trash. And we just have two buttons, not fish or fish. And so when we see the pictures, we're going to say, like this one is not a fish, not a fish, not a fish. There's a lot of not a fish. It's going to give information along the way, and I think this is why the grade level gets bumped up just a little bit, because none of this is capable of reading to the students, but that's okay. Again, if you are going along with them, then you can read for them. But we're going to keep programming. So we've only put 5 things inside of this AI bot, and I don't know if there's even been any fish yet. And so now we finally get a look at a fish. Well, that's a fish, and here's a fish, and it looks different than the last fish. And now we're back to not fish. And I'm just going to go through this here. And what it's telling us is AI is learning from our choices. And if we make a wrong choice, then it will also make that wrong choice because we put the information in wrong. And so, but I'm going to continue on. And when I get to 30, there we go. It says, great work. The more data you provide the AI, the more it learns. Keep training or continue. So I'm going to click continue. And what it's going to do is it's going to basically test out the program that AI has learned. And it's going to run through these, a lot of items, and it's going to just predict whether or not it's a fish or whether it's not a fish. So I'm going to click run. And it's right. It's right. It's right. That's right. That's right. That's right. That's right. That's wrong. That's right. That's wrong. That's right. That's right. That's wrong. So some of it is, and that one's wrong. It's getting some right. It's getting some wrong. And what we can do is we can click continue, and it will show us the objects that it identified as fish here, as well as the objects. We can toggle the switch over here to label the items that it did not pick as a fish. So as we look at it, we have all fish up here at the top, but we have some tires that got thrown in. We have this this, I don't know, can of oil that got thrown in here as well, but it did a pretty good job. If I go over to the not fish side, I see that all trash at the top, but we have this poor guy right here that got thrown in that is not trash. And so what happens is this is probably in here because my guess is it looked probably to the computer, it looked like a banana. And the way to combat this information is to just train more. And so I can click train more, and I can continue on and keep giving this information until I feel like it has enough in order to go on. And that number is not, you can keep training for the rest of your life if you wanted to. I don't know why you would want to, but we're going to stop. Let's see, now I got 50, and I'm going to click continue. I'm going to do it in double time here. Oh, okay, let one thing through. All right. So now the only thing that made it through that shouldn't have are these plastic items, right, that hold the Cokes. I can't think of what they're called, but there you go. But the rest of the fish, including the fish that I don't believe made it through last time, is there. And if I click on the not fish, then I still have this one fish that didn't make it through. Maybe it looked like an apple or something. I'm not sure. So it gets better though, because there were tires that made it through last time that did not make it through this time. And there was this bottle that made it through last time that didn't make it through this time. It gets better as you train more, and that's the idea behind AI, is that if you keep throwing data at it, it's going to start figuring out a little bit more information. Now, here's the thing though. If you don't teach computer science, this is just an activity, right? And yeah, there's things that you can inform your students of the interest that they might have in artificial intelligence as well. But again, we want to start thinking about in our classroom, and some of the real world implications that this might have, and the AI for Oceans goes into that as well. So I'm going to click continue, because we want to think about the real world, as I said, the real world implications of this. And so now it says, so far we trained AI to identify objects as either fish or not fish. But what if this training, at the beginning, we were supposed to clean up the ocean, right? So what would happen if to other sea creatures that we did not train this AI to do, or to have the information for? Well, here's a jellyfish, and it gets sent out. And there's a lobster, and it got sent out as well. So we didn't do a good enough job training it throughout. And bigger picture, and I'm going to kind of stop right here, and if you want to do more of the AI for Oceans, then I recommend that you take a look at it. We are only on step 3 of this lesson, and there are 8 total lessons, 8 total sections of this lesson. And just kind of think about, in the real world right now, they are building AI to identify people. They're building AI to identify facial expressions of people. And in one of those particular cases, they are they're building AI to be able to tell whether someone is being truthful or not. Now, this poor guy, this the red fish from the previous example, and this lobster or crab, whatever it is, here, they got lumped in the wrong spot because the AI was programmed in a certain way. And I think there's a good question to be asked, and a good idea that really, a societal question that can be asked of, what are we expecting our artificial intelligence to do for us? Is it these remedial tasks like telling the time and telling us random facts on the internet that we would normally have to watch Jeopardy to get? Or is it much beyond that? And so I think there's some questions that can go in that we haven't even asked ourselves as a society yet, that we could be having inside of our classroom, that are very important questions, but also ones that we can build research projects on if you are building, if you need topics on research, or anything, frankly, that is found in your curriculum that you can kind of spice up a little bit with some things that really, really matter. Not that the curriculum we have, not that the motifs behind it don't matter, but I think it's we can kind of change things up along those lines. And so my challenge for you, and I hope I mentioned this challenge at the beginning, but if I didn't, I'll be more clear here. I think the challenge is to figure out how we can use this inside of your classroom so that it doesn't detract from, and it's not just an additional thing that we do, but really goes hand in hand with the curriculum. How can you take this idea of artificial intelligence and go from there? And as sad as that, the AI I mentioned of telling whether someone is truthful or not, and the implications built around that, it's not all doom and gloom. There are some good things that do come out of this code, and I'm going to show you a video right now. And what this is a recycling center, and you can see that some things are being sent up, and here we got slow-mo. Some things are being sent up while other things are being sent down. And what's actually happening here is there are lasers that are identifying whether these items are plastic or not. And if it is plastic, a burst of air will shoot this the plastic items up into this section, and if it is not a plastic item, it will get dropped down into the trash. And so we have very similar to the activity that we just did, we have recycling centers that are doing exactly that. They're using AI to figure out whether or not the items are trash or whether they're plastic. And so so this is helping the environment through that AI. And so I think it's kind of good to show these real world examples as you go through, and let them know that it's not just a fun thing, that there's real world things that are happening alongside this. So now in the meet, I would ask for questions if you had anything else. Of course, since I'm just recording this, then we'll move on to our next experiment, and that our next code byte, I should say. And our next code byte is it's called Dance Party. And so we're going to go to code.org, and this time we're going to go to /dance. So code.org/dance. And again, I told you at the beginning that you have no fear. I'm not going to start dancing for you today. But here is the page for the dance party. And again, just like last time, there are teacher resources that include a lesson plan. And this lesson plan does go as low as kindergarten. But again, I think if you have a pre-K, you can absolutely do it as well. It gives you, again, objectives, preparation, links you need, vocabulary, and so forth and so on. So I'll go ahead and you can see the kids dancing in here. And so they are not coding, right? You do see some of the code in the background over there. But what I also want to show you here is, in addition to the lesson plans here, there is something called an unplugged activity. And what an unplugged activity is it takes the activity that they would be doing on a computer, and it puts it on paper. Basically, it makes it a hands-on activity that you can do inside your classroom. And so this one says no computers needed. That's what the idea behind the unplugged activity is. Learn coding concepts to choreograph a dance party together. If you are like me, that just is not a fun person to be around, doesn't like to dance, you might not have too much fun with this, but I guarantee you your kids will absolutely love it. And so if you click on the unplugged activity, again, here is the lesson plan, and it gives you everything you need in order to do this. And so just to kind of give you an idea of what this is, when I've seen it done, basically the teacher is the person that does the input, and the kids are the computer program. And so maybe they hold up the letter A, and if the teacher holds up the letter A, then the kids know that they need to do the floss. And if the teacher holds up the letter B, then the kids know that they need to be doing the dab, or whatever other dance is going on. And so this kind of goes into that, although there is more to it than that. And so you can kind of take a look at it. So going back in here, there are two parts to this. We're only going to look at the first little bit of the first section. So I'm going to go ahead and click start here. And again, it's going to give me a video on the beginning of this, but I've already kind of talked about it, so I'm going to skip through. And it does ask you to provide your age, and the only reason it's doing that, I think, is that it gives you a little bit more age-appropriate songs for this. Not that, if I pick 21 plus, that doesn't mean that there's going to be cuss words and all that stuff, but it just means that it's going to be geared towards a different age group. So I'm going to go ahead and do 21 plus and click OK. Now, because I'm recording this not in my Google Meet, when I was in my Google Meet, no one could hear the music, and I know you can. So if I blow out your ears, I sincerely apologize, but here you go. So what we're going to be doing is up here at the top. This is the actual coding that the kids are going to be doing, and so it always gives you a set of instructions up here at the top, and these instructions can be read to the students by clicking this button right here. So if you have non-readers in your class, you can still do this program right here. So what it's going to do up here, I'm not going to read the instructions. I'm just going to go ahead and click OK. What we're going to be doing is we're going to be setting up this code. And this code is using blocks. And this is a very, very popular way to get kids to kind of start thinking about coding without actually having to do all the typing that coding requires. That doesn't mean that they're not doing code. And that doesn't mean that this is completely dissimilar to coding, and I'll show you what I mean here in a second. So what we're going to be doing is we're going to be choosing our type of dancer here. So I'm going to click, I'm going to drag that over, and basically now we have it set up. It's when I set up my program, what I've told it to do is that I can either make a new cat or I can make a sloth. So I'm going to make a cat at the center, but I have a lot of options, at the center of my page. And here is my page here that it's going to run. And right above that, you'll notice that I can put on all sorts of music. They have teamed with all of these artists to have as much information or as many interesting songs as they can. So I am going to do, let's YMCA is always a fun one, right? So when I click run, I'm expecting there to be a cat at the center of my page, and the song that's going to be playing is YMCA. And there we go. That cat's not doing much. He's just kind of standing around, getting with the vibes, I guess. But as I said earlier, I want to also point out that this is, again, not dissimilar to what coding actually is going to look like, because over here on the right, it says that I can show my code. And when I do that, you can see that here's the setup button. And you know how it's nested here. So that was, that's the outline that they gave us. And it says make anonymous dance sprite. And we told it that it was going to be a cat, and we told the location that it was going to be at. If I wanted it to appear on the top left, these numbers would change. If I wanted to be a sloth instead of a cat, then this word would change. And the code is going to match what the blocks told it to do. And so again, it's good to go. Now, if you are teaching this, if you want your kids to have fun with it and you've never done any coding in your life, don't worry, it's okay, because there are videos along the way that the kids can click on and go with. And so I really do encourage you that even if you are, if you have trouble with technology, even booting up a computer, this is not about you and your knowledge. This is what the kids can do. So I encourage you to kind of take a look at it and check it out. So we're going to keep going with this one just a little bit. And so that is the first section. And so I'm going to let this run all the way through.
Young man, there's a place you can go. I said, young man, when you're short on your dough, you can.
And whenever it finishes, it says, congratulations, I completed the puzzle. So now I can continue on. And so there's a video that goes along with it, but I'm just going to, again, skip through. And now what it wants me to do is it wants me to take this and actually do what's called an event. And so the way that I like to describe this is coding as an entire structure is set up like a recipe in cooking. And you're telling what what items you need or the setup that you need, and then you're saying what needs to be done. And the way that the code works is that it's going to work from the top to the bottom. And so the setup, I'm going to make it a cat at maybe on the left side of the page, and But this time I'm going to include an event. And what an event is when the person that is on the opposite end of the code, so the person that's doing this, I guess the code will respond to what that user does. And what I kind of like to think of it as is you have your restaurant, and restaurants have all sorts of recipes and sets of instructions that they can follow to make these items. But they're not just making food in the back randomly. They are waiting for an event. They're waiting for someone in the front of the restaurant to order something, and then they know which recipe to use. So in this case, what we can do is we can make this cat on the left side of the page, and when the user, which would be me in this case, when I click the A button, this cat is going to clap. And so I'm going to put on, let's see, you can't touch this. There we go. And we're going to make this cat clap every single time I press the letter A. So I'm going to click run, and I'm going to be pushing the letter A.
You can't touch this. You can't touch this.
There we go.
You can't touch this.
There we go. And so because I followed the instructions and because I did what it asked, then it told me that I completed this puzzle. If I would have not pressed the letter A, it would have not completed the puzzle. It would have said you have to do something in order for it to work. So because I'm going to move on, we're going to do one more thing before we go on. So now we can make our, it says it's time for a dance-off. So we're going to include even more information here. And if you were in the meet, we did a poll where we figured out the dance moves that each sprite or each animal wanted to do, and but for this one we're just going to go from here. So we have our setup, and this time we're going to make a cat on the right and we're going to make a bear on the left, and they are going to have a dance off. And so whenever I press the letter A, then we want this bear on the left to do something, and in this case we will have them do, let's see, where's our floss? There we go. They're going to do the floss one time, but I need to add to this because it's not a dance off until both of them are doing it. So I'm going to now also do, when the letter B is pressed, then this cat can instead of doing the floss, he's going to do the this or that. And so now they can have their dance off. So let's pick a good dance off song. I really don't know. Uptown Funk, that one's fun. So we can do Uptown Funk, and I'm going to push A for the bear to do the floss, and B for the cat to do the this or that. There we go. Fun times. Alright, so I completed that, and I'm going to stop right there and kind of let you kind of play with the rest of it to check it out. But so now they're able to do a dance-off. And if I wanted to, I didn't have to follow the directions necessarily on there. I'm going to go back to it for one sec. And if I wanted to add another animal, I could also do that. I could add a sloth at the center or at the top. And I could make that sloth, when the letter C is pushed, I could make that sloth do a, let's see, the double down. And there you go. I want to point this out again as we think about, well, how can I use this in my class so it's not just something that's fun. If I were to change this, let's see, from sloth to cat, or if I were to change this from that to actually I'm going to go to B. So basically I've made a code that is incorrect. So when B is pressed, the cat needs to do this or that, but then it also says when the B is pressed, the cat needs to do the double down, and it can't do both at the same time. And so whenever I click run, he did one of them. He did not do this one right here because it works basically from top to bottom, and it's going to do this last. It's going to get this input as the last thing to do, and so that's going to be the thing that we see. And so So there's an error here. If I were to press A, B, and C, it's not going to do what I originally maybe thought it was going to do. The sloth is never going to actually do anything. And so how can we kind of use this? Well, I mean, if you think about, math class, just as an example, we want our kids to check work all the time and find the mistakes that they made along the way. And in each step, there might have been a mistake that was made, and we want them not just to look at the answer, not just to look at the thing on the left side of the page and say yes or no, but really to look back and say, why is it a yes or a no? And this, in coding, it's called debugging. It's called debugging your code. In math, it's, checking your work or whatever the case is. In language arts, we do rough drafts and we do, we look into those rough drafts and we make, comments on it, and we try to figure out, whether our paper is as pristine as it needs to be before it gets submitted. But again, that's no different than debugging, that happens in the coding. And so I think we can make those analogies to the kids and kind of go beyond there of how can it help us inside of our regular classes and kind of make some of those connections. Whenever we were in our meet, there was also, just some classroom management ideas that came up along the way as far as this goes, and the stuff that you can do, for those kids that need to get some energy out. And there's a lot of that can be available during this. So just again, my challenge again is work through this dance party, have fun with it. You're not going to break anything. Have fun with it and check it out, and think how can you bring this into the curriculum that you already have, so that it's not just a fun activity, but that you get some classroom. Something that will produce good students along the way. So just again, something to think about. So that's pretty much the end of where I wanted to be. I will share a couple of activities, additional activities. This next one is code.org/AI, and it's just going to give you a few more of the AI for Oceans. But at code.org, there is all sorts of items that are available for you to teach with. And in addition to that, and I will put this in the comments on the Cavern Crusade so that you can take a look at it, there is also some additional unplugged activities. I copied and pasted the wrong thing. There's also some additional code unplugged activities that you can work with. And so here it gives you, there's 4 of them, and it's for different age groups. These are always good to have around, that if the internet ever breaks for you whenever you're in class, not that ever happens, right? But if the internet ever breaks for you, then you have something ready to go, that they will, gain some knowledge and not just be, a throwaway activity. It's something that you can work with. So I will put this into the chat, but in general, code.org is going to give you is a lot of resources, a lot of free resources for you to kind of look at that CS and let your kids see the world a little bit different, and that's kind of where I wanted to go with this morning. So in addition to these CodeBytes, these bite-sized pieces of code along the way, there is also a session that I'll be doing, I guess by the time I put this out, that I have already done. But there's a session that will also be included in the Cavern Crusade that goes over code.org a little bit more in detail as a program itself. And so I encourage you, if you are interested in doing some of these with your kids, to go ahead and check out that other training as well, so that you can incorporate some coding into your classroom. Again, no matter what age level, whether you're pre-K, whether you're you teach seniors at the high school. So I encourage you to check those out. So I'll go ahead and stop talking here. As always, though, if you need any additional help, please don't hesitate to reach out to us. We want to help you in any way that we can. So, but with that said, I'll go ahead and let you go. Have a great day.